All right, so my name is Anil. I run an organization called as Cloud Enabled. We're going to talk about OpenStack Cinder behind the scenes. I delivered a couple of behind the scenes on Neutron and Nova. Since it's a storage conference, I thought of talking about Cinder because OpenStack Cinder is a storage service, right? A very quick overview for newbies if you are new to Cinder. Cinder is actually a block storage as a service from OpenStack. And it actually allows you to create storage volumes. If you use AWS Elastic Block Storage, where you have created a volume and mounted it to your VMs. So exactly same service you want to offer in your private cloud, we are looking at OpenStack Cinder there. So once you attach the volume, you can go ahead and format the disk and it will appear as a D drive, right? So in easy words, if you look at Cinder, think of Cinder like a D drive for your virtual machines. So that's the whole objective. It's not an object storage, it's a block storage. So why do I need Cinder? One of the best practices, maybe you have launched a VM in Nova, in OpenStack, and that's around C drive of 100 gig. Now you want to deploy Oracle database on it, and you know that Oracle database needs more storage space. Now you cannot grow the 100 gig storage to a 500 gig, probably you want additional 500 GB. You can always create a volume and attach to your VM. It will give you 500 GB more storage space. That's one of the use case. Second use case is cloud enabled, as in we do OpenStack consulting. We always recommend customers to put data on the Cinder volumes, not on the Nova VMs. You know OOPS concepts here? Anybody familiar with OOPS? How many of you know OOPS concept? OOPS in developer. I'm talking OOPS in operations. How many of you are familiar with OOPS in operations? Never heard before? No? You know, right mouse click, accident deletion of a VM. That's OOPS in operations. All right? Okay? So, tell me any operation guy sitting here never made a mistake. Right? Everyone does, right? As in, yaar uda diya file ko, you know? That's it. So, to overcome this challenge, like accidentally somebody deletes your VM, I still have that 500 gig storage volume, remember? I can go ahead and launch a new instance, attach this volume back, and this time do not format because it's already formatted drive, right? You can restore your data back. So that's the use case of why you should look at Cinder as a service. So some of the components, Cinder has a Cinder API. It's a RESTful. Yes, sir. No, they can't. Yeah, it's simultaneously a volume cannot be accessed by multiple VMs. I can detach the VM volume and attach to someone else, but one volume at one VM access. Yeah. What you do is you deploy NFS on this. On one of the VM you deploy NFS, attach this volume, mount this NFS to multiple VMs. No. Let's say you want to run Oracle rack, you can't. Yeah, if you're looking at that areas. It is purely a block storage attached to your VM, and it doesn't give access to other guys. So, but if you are doing Docker volumes as a Docker containerization, a volume can be shared to multiple containers. That's the scenario, because they use more of an NFS shared, and here we're talking about block here. Yeah. So same rule applies old school days. If I have a EMC SAN volume attached to a single VM, right? So it's accessed only by him, right? Same rules apply here. So Cinder API is a RESTful API where whenever an end user comes onto OpenStack dashboards and clicks on create volume and clicks on submit, that request lands up to the Cinder API. He's the one who receives it. Then we have Cinder Scheduler. So this guy is the one who makes the decision on which particular storage system to create a volume upon. So let's say I have EMC SAN and HP as well, and probably SSD and SATA. The scheduler decides on which particular storage to cover in this particular volume request which came from the client. And finally, there's a Cinder volume service itself. It is the one who is routing. He's doing the guy like, you know, the heavy lifting. All of that work is done by the Cinder volume service on the back end. So this is Cinder, and I love Cinder for this, right? So broadest portfolio of backend support. So you can have Cinder, which is front end for your OpenStack storage service, while your best of the breed storage system like Dell EcoLogic, EMC, Fujitsu, GlusterFS, Hitachi, 3PAR, IBM, NetApp, Huawei, the list goes on, right? So I could not populate here, but the broadest ever in the history of open source projects, which is supporting the storage of your choice. But I cannot go ahead and replace Cinder. Cinder will be the guy who will talk to the multiple backends on the storage systems. Cinder Backends, how it works, so we have Cinder API, then we got Cinder Scheduler, then backend we got Cinder Volume Service, and behind this I could have all SATA disks. So maybe I can buy a commodity server which is an Intel or AMD platform, load some OS on it, install LVM, attach bunch of SATA disks on it, right? So I can configure all of this SATA pool as one of the storage system to my Cinder service. That's one option. So I like proprietary products, so I have an EMC SAN already invested on a VNX. It's running a 15K RPM disk. I'm good with that. So there are drivers available where Cinder can talk to EMC SAN as well. Then I have HP 3PAR probably running all the SSD drives. So if you look at client A, ABC Limited, operating out of New York, he can provide storage as a service to his own employees on 3 different categories. One is open source SATA on LVM, and we are talking EMC 15K RPM and SSD. So in private cloud, if you want to offer storage as a service, so Cinder does allow you to give multiple tiered storage service to your clients at this moment. Yeah, yo, just one slide away. Yeah, okay. So this is the configuration file. I don't know how many of you can see it from the back. Let me give it a try. You don't? Okay. So basically you see there, I have a configuration like LVM driver 1. In this section I mentioned which is the backend storage system you should talk to. Similarly, I have a 3PAR section here. I give the 3PAR related backend details. I have an EMC section here with the EMC details, right? So basically in Linux everything is config file, right? So it's a file is all makes Linux today. In the config file I mentioned what kind of systems I want to backend support, and then it will start talking to the relevant storage systems for us. Okay. Now Cinder behind the scenes, there's a live demo for you guys, so that's why I'm going a little faster. So when you see it, visualize it, you'll see the awesomeness of it. So basically clients are interacting with OpenStack via Horizon. That's the self-service portal. It's like aws.amazon.com for you guys. So we have Horizon in OpenStack. So end user comes in there and is actually requesting for a volume of let's say 10 GB on SSD. And you know what SSD drives we're running on? Which storage system? That's on 3PAR, right? Yeah. So let's take an example that we are trying to provision 10 GB SSD drive, and that request lands to Cinder API first. So in between there is something called as RabbitMQ server. That's a messaging queue used in OpenStack. So he's going to send a message saying, okay, I need a volume for one of the client. So Cinder API receives it, and then Cinder API will authenticate that request with an APMQ, take that message, and it's going to pick up that message and send it to the guy who is Cinder Scheduler, that here I have a request of 10 GB on SSD. So that's what Cinder API is going to talk to the Cinder Scheduler. Don't attempt to read it, none of them can read, it's been very tiny, but the slide share are there where you can read it further. So basically Cinder volume will take that request from the queue, but interestingly if you notice here, it's going to check on which availability zone to provision it, which volume type to provision it. So Cinder Scheduler makes that decision making. So finally Cinder volume will invoke the backend driver. You remember in the config file I gave the driver name LVM driver 3PAR. So it will invoke, if I have used SSD, it knows that it has to invoke 3PAR driver now, right? So that's what we have promoted. That's a configuration file. So that's gets into Cinder volume service. So based on the protocol it creates the volume, and when the volume is created it will report back to the Cinder API, because remember the end user is waiting on the portal. He clicked on create volume and is waiting for the results. So Cinder API will take the request from Cinder volume, that's the volume is created, and finally he is going to respond back to our Horizon that the volume is created, and in your dashboard you see volume created successfully. So that's the message you receive. Yeah. Okay, it's all Cinder Scheduler at this moment. when you talk about LUN masking in your old school days, like in EMC at the fabric level. Yeah, so here we talk about keystone concepts. It's a multi-tenancy environment. So each project has a designated ID, and all the volumes you create are part of that particular project ID there. So in that case, the isolation is not like a LUN masking here. The isolation is based on the projects. Only if I'm Anil is part of project A, I create 10 GB volume. I'm the only person who get to see it, or I'm the only person who can attach and detach the volume. But project B, he could be the administrator as well. He cannot go and get access to it.
But the host mapping also has to happen.
Yes, so that is done by the consumer. Yeah. So it's all about self-service. I'm sure there have been so many talks on software-defined storage, right? So we are talking about self-service portal, which allows an end user to create a volume, create a VM, attach a volume to his desired virtual machine. So there's absolutely no administrator involvement required here. Yeah.
Vendors provide identical kind of storage. So how is Cinder Scheduler going to differentiate it? Say, for example, all of them are providing SSDs. Take for example.
Oh yeah, sure. So basically, right now, how it designed is scheduler decides where to create the volume. Let's take an example. It's round robin actually. So let's say we have 3 storage system, all SSD, and the customer has asked for SSD drive again, right? So now where do I provision it? So it looks at the optimal block storage. Probably storage A, it has a database which captures storage A, how much is available, how much is used. So basis that, whichever is less provisioned or less utilized, it's going to identify that and provision volume on that. But if you're good at Python, you can change the way it behaves. You can say every time somebody creates a volume, you can go concatenation. I say that, okay, fill up this storage first, then go to next storage, then go to the third storage. So it's completely configurable. Yeah.
You can create it parallelly. Like I'm asking in the sense of scalability.
Sure. There are no benchmarks which have been done so far. It all depends on your Cinder API capability. So Cinder APIs are stateless. You can have like hundreds of machines running Ubuntu with Cinder APIs on them, right? So if you have more Cinder APIs and you have a virtual IP on the front end, you're trying to distribute your workload to multiple guys. So it depends on the scale of number of Cinder APIs you have provisioned. But 100 is not practically possible. People do deploy around 3 Cinder APIs on 3 different controllers for a production.
Okay. And is the scheduler highly available?
Yeah, it's also stateless. See, what is stateful here is only database. Let's say I have Cinder API and Cinder Scheduler and Cinder Volume. I can just go and delete that controller. Build up a new one, DB sync, I'm up and running again.
Okay.
So absolutely there is nothing with the APIs here.
Okay, thank you.
Yeah. That's all managed by Keystone. And volume attached information is there on the Cinder database, remember? So which is the volume created, ID of it, which VM is it attached to, that's all in the database. The next time any Cinder API comes up, he reads the database, he knows what it is, looks like. It's like a person resignation at your office, new guy comes, there's a knowledge transfer, right? So database has all the information relevant. And this is same with all the components of OpenStack. No, not really. So it stores information like how many volumes are there in the cloud, what is the ID of each volume, and this particular volume ID is related to which particular tenant or the user, and the status of that volume, is it attached? If attached, to which VM? If detached, the state of the detachment. So all of this relevant information is stored onto the Cinder database. It's not just configuration. It's also the same thing, like config is LVM drivers, 3-part drivers, information about what is the HP 3-part storage system configuration. All of that is there. But moreover of that, you have the storage infrastructure knowledge as well.
I have a question. That Cinder database is, where is that stored? I mean, that is behind the...
Sorry?
Where is the Cinder database saved and is it highly available?
Okay. Cinder database, ideally OpenStack uses MySQL. You can use Postgres as well if you wish to. And MariaDB, that's another option. And natively MySQL supports replication of async. But if you're not very happy with async, the problem is Cinder will be talking to a MySQL database which is running on, let's say, 1.21. Should 1.21 fail,
Yeah.
I have 1.22 which is my async replication, right? The problem is there's a downtime. I have to go to Cinder configuration file and tell him, guy, talk to 1.22 and not 1.21. So I go to the configuration file cinder.conf, I mention the IP of 1.22 there, restart the service. At that time, worst case what happens, new volumes cannot be provisioned, right?
So this list of database, the hosts which are giving this database service is known to us before, or
List of?
this Cinder database?
Yeah.
Those IPs are known.
It's all there in the cinder.conf.
Okay. So,
Yeah, so we are telling Cinder whom to talk to, where my database exists.
Okay.
We already told him.
I see.
And since we are told it is on 1.21, he will always attempt to talk to 1.21. He doesn't know that 1.21 has died.
Okay.
So I have to go ahead and tell him, boss, now talk to 1.22. So if you don't want that kind of scenarios, I'm not sure if you heard about SQL Galera. So Galera is active databases. So it gives you virtual IP capability. Now we are talking about in Cinder conf, you do 1.23. While backend you have 1.21 and 1.22. So in case of 1.21 failing, he will redirect to 1.22 automatically. Plus, it is always sync.
Okay.
So that's the best way to deploy it.
Okay. Thank you.
Yeah. Yeah. Okay. See, I'm not sure if you. I spent 4 years with EMC before, also on storage. See, any API will have an overhead, right? As in, you can't avoid it. But the awesomeness of the kind of number of storage system it is providing, the awesomeness of the storage policies it is giving, that can be easily discarded, right? So the achievement here is we are talking open source, no lock-in, and you're able to achieve existing storage can be used in your OpenStack cloud. You don't have to buy a new storage system. But yeah, APIs do have overhead because you have to go through 3 layers before you reach the end product.
Yeah.
Yeah. Okay, see there are 2 parts. Storage replication is to protect my data recovery, right? So I have 10 GB volume attached to VM1. I have 5 GB of data on it. I want to replicate that data. That's where storage replication comes into play. Okay, database you have to handle separately, right? Database is storing your stateful information. So only MySQL can replicate the database. Otherwise, you put the database on a storage system again, like traditional old school days, and allow your storage to manage the replication of your database. But he doesn't have awareness what is it stored. For him, it's just a block of information he's just shipping to other guy. As in, it's not a database aware replication, right? As in, just for him, it's like another file, just pushing it off. So natively database, you should use it with a replication natively, while your storage system is a replication of your data alone. That's your PPTX, all those files. Oh, you can. Yeah. But how many of banks today run? There are many banks who run Oracle database today, right? How many of them run storage-based replication? They invest like around $1 million on a storage system, but how many of them use storage-based replication for database? Yes, of course, database consistency. I need a replication software which is aware of my database. Any storage replication software on this earth, irrespective of the vendor I want to quote, it will only see block A, shipment to block A on other side. That's all. It doesn't matter it's a data coming from a database or it's an anil.ppt block. For him, it's just a block of information. Like Oracle Data Guard is a very good example. So Oracle Data Guard does all the awesomeness for you, right? It keeps your database replication to other side, it's keeping the redo logs, you can retrieve back. So always look at database as a native, or you can have replication software which are database aware, which can do it for you.
Had a quick question. Is there a option here to configure the multipathing requirements or Aluva and things like that, or balancing policies?
No. So that you do it at the hardware level.
Okay.
With Cinder, no.
Okay. The host side also we might try to.
Yeah, host side multipathing, you have dynamic multipath, DMP on Solaris. You have a Veritas solution for multipathing there. So that is host side is still the way old school days.
Okay.
From a Cinder perspective, you can't think of the hardware way which we used to do. That's not possible.
Okay.
Yeah. All good? Okay. Alright. So finally what happens is client will get the details, the UUID for that particular volume which got created, and the state of that particular volume. That's it. Okay. Okay, quick marketing talk, then I'll get on to demo. So that I want to forcefully, I want you to hear me, right? Okay, so we are cloud-enabled, focused on cloud and DevOps, consulting, implementation, and trainings. We have offices in New Jersey and Bangalore. In Bangalore, we have a team of 13 engineers who work on OpenStack. So we are a global SI for OpenStack. If you go on OpenStack portal, there are only 15 system integrators capable listed there, and we are one of them. That includes the big companies in the world. So though we are a 13-member company, I've taken my company to a level where we can talk about OpenStack skills. We deploy around 200 OpenStack servers a month. I'm not sure other vendors how many they do, but we are large in OpenStack, and this is all operated out of Bangalore. These are skill sets. So we deploy OpenStack clouds. We have a government's cloud data center deployed completely by cloud enabled and managed on OpenStack for 3 years with L1, L2, L3. Okay, and this is my support team. I call it as enthusiast support team. We are trying to redefine in a small way. We don't pinpoint that, okay, there's a network issue, go fix it and come back. We kind of liaison with the vendors and try to fix the issue for my client rather than pointing to somebody else. So that's what we are trying to redefine in a small way. We do OpenStack and Apache CloudStack deployment and support. Okay, there's an e-learning platform which is announced. We have OpenStack, DevOps, public cloud, and SDN. So it's an emerging technology e-learning platform, and the link is training.thecloudenable.com. So what is exciting here is we have a 90 days access to e-learning on all these courses. And guess what? I got a $20 course for us. Right? But only essential, guys. So this is like marketing. So all the essentials on DevOps, which is Jenkins, Docker, Chef, Puppet, and OpenStack Essentials or AWS Azure will be at $20. And support on email if you have issues. We have advanced courses which is $100 and above. So if you want to go to intermediate level or expert level on OpenStack. These are ratings. We have been rated 5-star out of 5, all 4.5 years now of cloud enabled. And let's get on to the demo. Let's see Cinder in action now. Okay. So what I've done is, just for demo purpose, I provisioned one OpenStack cloud on a AWS EC2 VM. All right. So hopefully demo should work. Okay. Don't blame me if there are some issues. Right. So this is OpenStack running on Amazon right now, just to avoid issues with PCs. Right. So typically, OpenStack login is on the Horizon portal. So I'm going to log in as administrator here. Right? Sorry. So if you notice from an admin perspective, I've created two kinds of storage systems here. One is called as SATA, another is general purpose SSD. All right? Just for demo purpose, there are two different backends here at this moment. And the way it's configured is, okay, you can read it from there, or should I make it white? This is good? Okay. So if you notice here in Cinder, I have given enable backends LVM driver 1 and LVM driver 2. I could have just went with other options like EMC. Right? So then for every driver I mention here backends, I need to have a section for it. So I'm saying for LVM driver 1, I want to use a volume group by name Cinder volumes 1. And I want to name this backend as SSD. This is what customers are seeing on the front end. Like when you go to AWS, you see general purpose SSD and magnetic, all of that. So this is the backend behind the scenes in OpenStack, we can do it. So similarly, LVM driver 2, I have attached it to SATA disks. And if I want EMC, what I could have done here is just go ahead and add another section here. by EMC and start providing the values to it. So you can start enabling multiple backends on Cinder. And about the database which we discussed, this is what I am telling database connection here. So I have a single IP, 1.21. It's not a virtual IP, single database just for demo. But if you have Galera cluster, you'll get the virtual IP in this case. So this is what I was telling. If 21 is down, I have to come back to cinder.conf, change the value to 22 and restart Cinder service. So that's the downtime which will occur. And these are all keystone authentication, other things, that's okay. So let me do a VG display here. So we have Cinder volumes 1, which is 10 gig in size. We also have Cinder volumes 2, which is another 10 gig of size. So this is how the mapping is from the Cinder perspective. So we have to run some commands like VG create and all of that. So that's already been done. So let's head back to the portal. So this is volumes here. So what I do is I'll actually create one project quickly. Let's call it as SNIA. Okay, please work. All right, it's working, good. All right, so create a user. Say Anil. All right, and so as an admin, I'm creating a user, adding him to the project. Okay, it's already in use, so I'll just make it Anil P. Okay, so that's done. So if you look at projects, the project I created is SNIA here. You can always modify the quotas here. So you can decide how many volumes can this particular project can create. So that's what you see in AWS. Normally you'll have a restriction 20 VMs on each EC2 region. So it's also a soft limit in cloud. You can give higher values. So let me change it to 15 here. And how many snapshots can he take for that particular volumes he creates? So I'm going to make it 15 for now. Total size of the volumes. So he can mention how much size of storage he can consume from my cloud storage. So that's a terabyte here. And click on save. And just sign out here and log in as the user. So on the user dashboard, he gets to know on the storage consumption he can do. See, up to 15 volumes he can create. And consumer also knows how much of storage space he can consume out of the entire cloud. Now, the only challenge with current OpenStack is it supports at the volume quota level at the project level, not at the individual user. So if I create one more user, Ajay can log in and consume all the 15 volumes. And Anil will be left out with single, 0 volumes there, right? So that's the only challenge, otherwise all good. And customer goes on volumes. And when he clicks on create volume, he can name it like, just want to say SATA 1 gig. This is where he gets to list. This is what admin has created, remember, as cinder.conf. So he gets to list what are the services available. If I want low performance, I use SATA. Assuming SATA is running on LVM, it will get created on the LVM storage system. So 1 gig size and click on create volume. So what happens is behind the scenes, same thing. Cinder API is the one request went now. Cinder Scheduler followed by Cinder Volume. Volume designated this task to the LVM now because it's using LVM there. Yeah, and the SATA disk is created. So customer can go ahead and manage attachments. He can attach this to any VM which is already running. So once attached, he is using for last 20 days and oops concept happened. He can always launch a new VM and attach back. This is what I was explaining. Other thing he can do is just to back up his volumes. he can take a snapshot. Yeah, that's like a backup. Yeah, you can. Yes, it's live. In fact, if you're running database, it's not recommended because your consistency issue will occur. But OpenStack will not look at it. He'll just go ahead and take a snapshot for you because it's not application consistent snapshots. This is volume snapshot. Yeah. So that's why what you should do is you should always, if you're backing up for databases at least, unmount your disk first and then take a snapshot. Otherwise, you have a problem. Yeah, so that will sit on the app level again. So that has been there before also, right? So we have many solution from software vendors. They give you plugins for MySQL, Oracle, and all. Exchange also they allow you to do application consistent, but that is native to application level. But if you're talking about only Cinder, natively he will only just take a snapshot. It doesn't bother what you got there. So try to run a combination of it. Otherwise, you'll have a challenge. No. Yeah. So that's not there yet. Yeah. As of now, I did not see anything on Cinder working group on that areas where they are looking at application consistent backups. They're just focusing on volume backup, how fast they can take it and all of that. It's all about speeds. That's what they are getting into. No roadmap as of now. Yeah.
There are some special purpose storage controllers which provide some facilities like hearing, etc.
Yeah.
So that facility
You can leverage here.
you can control that as well.
No, you can't. So let's say you have a quality of service from your storage vendor and let Cinder to control it, it will not happen. Cinder will just tell the EMC storage that yes, I need a 10 gig volume. Now that 10 gig volume, there's like hot data, semi-hot, and cold data, right? So cold data moves to SATA, 15 kRPM has the nearly active data, and the hot data is on the SSD drives. That is managed locally from the storage system. So that algorithm built in the storage OS itself. That this guy will not be aware.
But there is something called as quality of service there.
Yeah, we have. So this quality of service is different from what he's referring to. Yeah, you can. Okay. Correct me if I'm wrong. Here we are talking about two quality of service. A quality of service from Cinder is different from quality of service from the vendors. It's movement of data which the LVM driver and the EMC driver we are talking about is managed by Cinder himself. When I go and the block sits on the EMC disk, that is from there onwards, that entire block, every block is managed by EMC SAN. Yeah.
Quality of service parameters which driver can expose can also be.
Yeah, which can expose, yes. But at this moment.
Can be programmed with this quality of service
Okay.
as well.
All right. Thanks.
Are there
Good.
plugins to other hypervisors like VMware, etc.?
Okay. So there's another software component in OpenStack called as Nova. Okay. So Nova is responsible for integration with hypervisor. When people say that OpenStack supports multi-hypervisor, we are talking about OpenStack Nova software supporting it. So Cinder is to do with more of storage service, while Nova is to do with the compute, where it supports VMware vCenter, Microsoft Hyper-V, Citrix Zen, and KVM.
Can the Cinder volumes be exposed to
Oh yeah,
Nova? Yeah.
200%. Okay. Any hypervisor supported by Nova, Cinder volumes can be mounted onto it. There's absolutely no issue at all. In fact, the current one I have deployed for government is OpenStack Hyper-V with Cinder volumes attached to it. So Cinder is attaching volumes to a VM which is running on Hyper-V infrastructure. It's vendor neutral, that's the awesomeness. I think 680 companies are actually contributing to it. I started with Havana release 4.5 years back. The cloud-enabled inception itself has been OpenStack. And because of that investment, I could invest on US office now, thanks to OpenStack. By the way, I'm the first brain on the planet who developed expert training on OpenStack. There's no second brain. And that's not self-claimed, that's right there on the OpenStack portal. Right? So no attitude issues. I just want to tell you guys that I'm the best in OpenStack training at this moment. Services, we are already kind of getting there, but we are able to manage full-fledged a government cloud data center on our own. We don't further outsource. Huh? Yes, sir.
So is it compatible with Swordfish?
No, I can't answer this. I really don't know.
Because that also provides kind of management.
On which side? Cinder side?
Yes, swordfish, yeah, storage.
Okay, so it's very easy. Cinder has the compatibility matrix on the portal itself. It lists everything. They keep adding new infrastructure. So there's a Cinder compatibility matrix which you can refer to. It will list all the storage systems which is supported.
The plugin is provided by the vendors or plugin?
Okay, it's co-developed. At times what happens is, let's say you developed a nice storage system, like somebody spoke about open source. You develop a storage system. Now, community is not interested in it. Then as your company, you have to contribute and write a plugin. But let's say it's a EMC storage system, then EMC, a lot of people, community users also are accepted to work on it. So it's a combination, either community shows interest on it, then community also participates, or co-develop it, or if you are a newbie and you expect to sell your product, then you get going with your plugins.
So in that case, the plugin is developed by EMC, you can decide to choose whatever API based.
Yeah, of course. And today everyone is exposing APIs, right? So earlier it was like very locked in kind of thing. How many of you understood that how storage OS works, right? And then today, thanks to open source, we really know what happens behind the scenes. And I'm actually making an effort to develop object storage, but that is like a lot of work to do, but we are trying to get there. Yeah. So I'm out of time and I'm good. Thank you so much. I'll be just here to take your questions. Thanks so much for your time. Bye.